Uh, Thanks for taking the time and answering the question. And as you saw yesterday, we had quite a lot of discussion going on. What exactly is the difference when it comes to the industry per se? So I'm kind of trying to weave two different aspects of design over here. So one is learning about the powertrain per se, and second is how do we do it probably from a OEM's perspective. So today also I'm gonna try and somehow try to take you on a parallel track, but I will have to pay a lot more of attention towards the OEM track, right? So how do OEMs basically do that? I'll have to basically go from there. So the reason for that is primarily because the gap is large over there, as you're also aware of it. So I'm gonna try and see if I can plug that gap, plug kind of like what we typically do see in terms of like how you'll have to adapt it for the industry use case. So if you remember yesterday's discussion that we had, we were talking about some kind of industrial processes that we will have to follow. And without those industrial processes, things are going to be difficult for us to support it, right? So today we will start from the same, area, and we'll see how we can do it. We'll do it manually. See, you'll have to understand that these are usually steps which an entire department does. Not many people kind of like do the entire end-to-end coverage of it. There is no single person who does it. So usually it is an entire department which is responsible for doing it. So keeping that in mind, what we'll do today, I mean the agenda for today, it's going to be something like this. We are going to take two different requirements, right? And we'll try to see how we can drive these requirements, how we can develop these requirements, and where does this requirement actually lead us to? We are going to see that, right? So that's basically like what we are going to be working on, right? So let's start from there. But since I said that we will start from a battery side, we will probably start this over there. We'll start it from a battery side. We will take some two very innocuous looking, very innocent looking requirements, and we will see how this expands into a multiple page Excel sheet where you'll have to have quite a lot of considerations being done for it, right? So let's start with the battery side, right? So you probably are aware of what the battery is, how it basically works. So the fundamentals, I'm pretty sure that everyone's already aware of it. So I'm not going to go and bore you to death speaking about battery chemistries, how do you put batteries together, series and parallel. I don't think I will have to actually spend, in fact, any time on it because for the most part, these are some things which a lot of us are already aware of, right? So what I'm gonna do is systems engineering for EV, right? So let me just share my other screen. I'm gonna keep switching between two different systems, right? So that's the only way I'm gonna be handle it. Multiple partners to share, only one person can replace current share. Okay, so I'm gonna share a different window. I'm going to keep switching between the two. Unfortunately, that is the only way that I can manage this. So please bear with me while I do this, right? So like I was telling you, we are going to start with the battery systems. We can have batteries or we can also have one from the motor, right? So we will probably do that. So I'm gonna probably have to use two different systems here. So let me also see if I can just give me a second. I'll see if I can share my entire screen. I think that would be better. Okay, so the entire screen is shared. Great. Okay, so let me also open up an Excel sheet. Um, So, like I promised you yesterday, I'll be sharing this Excel sheet also with you. So you would have the Excel sheet. You would also have I'll also share whatever notes we write out here. I'll try to share this as a PDF or something. I'll just try to export it and share it with you. So now let's get started, right? So like I said, we'll start with the battery systems, right? So now when we speak about a battery pack, right? At least current day from an industry perspective, what are the questions that I need to be asking about this battery pack? I mean, we've kind of reached a point where there's not much in terms of innovation or in terms of any kind of like very different approach which keeps happening, right? So for the most part, battery pack design is frozen as of now. And the only questions that we ask anytime that we have a new project coming up, and anytime that we need to work with these and kind of try to understand how do we build a battery pack, there is very few questions that we usually ask. Okay, so it's like this. So the first question obviously is chemistry, right? And with respect to chemistry, LFP, I mean, I'm talking about a smaller company. A larger company might just call a blade and just get them, I mean, BYD and get blade cells. But if it's a normal smaller company, do you want to go with LFP or NMC chemistries, right? So the first decision that you need to take is basically this. And the way that we do this is LFP is basically like if you're building a cheap product. Not exactly so, but basically because LFP, the cells are cheaper and also it is more tolerant of temperature and things, which means you can get away with using a cheaper BMS. You can get away with not doing a complete, analysis and things like that. You can basically do away with a lot of things, right? So if you are doing a cheaper product, LFP works. NMC is more expensive, but it is energy dense, right? So wherever you are looking at power to weight ratio, where you have more mature processes, right? So things like this, you go with an NMC. But right now, if you ask me, I would say 90% of all the work that happens, it all happens with LFP. So people are not even considering NMC because the cost differential was so huge that it did not make sense for us to go with NMC. But over the last 2 months, right, last 3 months, thanks to the Iran war and a lot of things like that, the prices have been rising, right? So LFP prices have gone up by about 20-25%. They are nearing NMC, but we don't know what happens, but it is kind of nearing NMC. Now, this is also the biggest risk that I spoke about, right? Remember China? Right? So that is the risk that we have here. Anytime that you decide to go with an LFP or importing it, there is always a supply chain risk, and you'll need to figure out how to manage that risk. It is a very big risk. We've been caught out because of it, and that is something which we need to be extremely careful moving forward also. So I'm going to go quickly through it because I'm sure that you're all aware of this. I'm not going to spend too much time. So once you do this, then you would basically be working on your pack configuration, right? So configuration again is a pretty simple thing. You just do series and parallel. So you do either MS, NP or NS, MP, right? So though more often than not, what we do is we try to like kind of like have the series first and then the MSNP is what we do. NSMP we don't usually do because of the amount of balancing, self-balancing current which will happen. So MSNP, where you can replace it out as modules, is basically what we prefer to be doing. So now once you're done with it, then you'll have to go for the actual manufacturing, right? So until here, this is basically design stage. So now you will have to go for manufacturing or manufacturing considerations, right? So you go to manufacturing consideration. Now, the only thing that you would probably think about is what is the form factor that you look at, right? So if you are a small OEM, you might go for prismatic cells. If you are someone who wants to make it for a larger purpose or something, you might go with cylindrical cells. So cylindrical cells, are you going to use 18650? Not many people use that. So 32XXX or 31XXS. I mean, I don't remember it off the top of my head. So 26 or something like that. So what type of a form factor you're using? That is something which we do. So once you're done with it, then the next one would be you will do some simulations, right? So the simulations here can be detailed CFD. Sometimes it can be 1D. You might do it in MATLAB Simulink and get away with it. You might run some Python simulations, but basically you'll need to run some simulations to understand how can we operate the battery pack. I mean, that's it. Most of the times, a lot of people don't actually do any simulations also. All they'll do is they'll go back to the supplier, right? And they'll tell the supplier, hey, this is what I'm doing. And the supplier would say, okay, 0.5 C is basically what you can do for charge and discharge. And if you're using it in India, then you'll need to have a liquid cooling. Usually they'll do this, right? Just to keep things safer, they'll say liquid cooling. But 0.5 C technically does not require liquid cooling. But in the future, if you're kind of upgrading it, if you want to kind of bring in 0.75 C or 1 C charging, fast charging, and things like that, you might need a liquid cooling. That's it, right? Trust me, that's all you do. You do not actually sit and think, can I make my battery pack innovative? Can I do this? Can I do that? It doesn't really happen because I think we have reached a point where the technology is getting matured. And right now, all that we are worried about when it comes to battery pack is just two things, right? So the first thing that we worry about when it comes to our battery pack is that how reliable is the pack going to be, right? And the second thing is what is going to be the durability of it, durability, or what is going to be the life cycle. I mean, aren't they the same kind of is? It can be reliable, but if it has a very short life cycle, or it is not reliable, but it lasts for a very long time. So basically, because the battery pack usually accounts for about 50% of the BOM cost, right? So the bill of material cost, almost about 50% of the BOM cost goes into the battery pack. So in order to work around with it, what we do is we try to make sure that um, just give me a second. Just give me a second, please. Sorry. Right. So yeah, so that's basically what we do, and we try to just answer these questions. So now reliability can mean a lot of things. It can mean like, is it gonna undergo thermal runaway, or is it going to be like safe in case of like some accidents or something? There can be a lot of things which can be there, but let's just leave that aside, and let's now try to figure out what could be the requirements which might come from a battery pack side, right? Let's kind of like see like what exactly is going to happen with it. Let's now go back into the Excel sheet, and let's see that if we can kind of write a requirement for it. Okay. So now when you write a requirement, there are usually some standard conditions that you might need to follow, right? So like for example, what happened? I'm sorry, give me a second. This seems to be stuck. One second, give me a minute. Um, Not working. Okay, just give me a second. Let me just close it and reopen it. Right. So let me just enlarge this. And so now when you write requirements, you should always start with a requirement ID, right? So I mean, it is a de facto standard that you have to do it like this. So we'll write a requirement, and we'll also write a reason, or we can write a category first, right? What category it falls under, and we can also have a reason. So now the way that we are doing, it's basically because there's going to be multiple teams, and suppose I've written the requirement, and I'm getting a team to basically go through this and tell me like if everything is okay or something like that. They need to understand why in the world did I do something like this? What was the rationale behind it? If I don't do it here, then every time someone has a doubt, they'll have to call me up and ask me. And in an organization where there are probably like 100 people or something, that's usually very difficult, right? So let's kind of like leave that out, and let's just stick to whatever we start with, right? So this is basically going to be we'll call it as ST RS. STRS stands for stakeholder requirement. Stakeholder is your client. Now, assume that a client, a company, has approached your college or your department and they're saying, design a battery pack for us for an electric two-wheeler. I mean, this is what they would usually say, right? So let's just put it out here so that we have that here. Let me just suppose a customer comes and says, design a battery pack for my electric two-wheeler, right? So they say this, then you say, okay, hey, you know what? We can't basically like do it like that. We need to look at like certain other parameters as well, right? One second, please give me a second. Um, Sorry. Evaluation is going on, so I keep getting text from the teaching assistants. I'm just, getting back to them. Sorry about, interrupting. Right. So design a battery pack for my two-wheeler. The customer, I mean, the client has told you that, and they say that we have a budget of, let's say, 1.5 lakhs for the pack, assume, right? And they say that we will pay you design charges of around 4.5 lakhs, right? This is all they say. We can afford to pay you design charges of 4.5 lakhs. Of course, if they're paying 4.5 lakhs, then they'll ask for pretty much everything under the sun. They'll ask for a CAE, CFD, whatnot, whatnot. They'll ask for everything because they're going to be paying. I mean, everywhere customers are like that. But leaving that aside, now suppose they ask us this, then obviously we need to go back and ask them some more questions like, hey, what exactly is the weight, right? What exactly is the range that you're looking at? What is the motor that you're using? What is the performance figure that you're looking at? What is the life cycle that you have? What is the use case? Is this going to be used inside the city or highways or what exactly it is? Give me some kind of an idea, right? Do you have any USPs? Are you going to say there is not even a single nut or bolt in my product which is made in China? Indian Army asks for that. Are you going to do something like that? Um, Basically, you would not just immediately agree to what they say. You're going to go back and you're going to tell them this is not enough for us to do. You'll need to give us more. You'll need to tell us a lot more of all these requirements so that based on these requirements, we can design a battery pack for you, right? I'm not checking on the Give me a second. I'm not checking on the chat window. So if anything's coming in the chat window, uh, let me just check if there's anything. Okay. I hope there's nothing in the chat window. Where is Zoom? One second. Where is Zoom? Uh, okay. Give me a second. Okay. Yeah. No messages. Great. Okay. You're now able to see this, right? Let me, no. Okay. Great. Okay, so now how do we come up with the requirement in this case, right? So that is the question. So we have this, how do we come up with the requirement? So let's say that there is a lot of other requirement, but one of the requirement that we're going to have is um, the BMS shall be capable of maintaining, uh, again, safe cell temperature within the operating environment of around 15 to 45 degrees Celsius, right? So this is basically a requirement that we have. I mean, we've just written it ourselves. So we are saying that Okay, this comes under the battery, so we'll give it as BMS. So we'll say BMS hyphen 001. Some requirement ID we need to give. And what is the category this falls under? It can be performance or it can be safety. Safety is always a higher priority, so we'll put it as safety. Category can be performance, safety, functional, it can be design, it can be user requirement, right? It can be standards, right? So now we can say the battery pack shall be compliant with AIS 136156. I don't know that there is the new AIS standards which we have for India. You will need to meet this. User requirement. Suppose the user says battery pack shall be uh, capable of being carried by hand by a single person, because they say that I'm using it for delivery, someone has to lift it and go. It's a user requirement. Design, right? Battery pack shall be of a swappable design. That's when you can remove it and take it and go, right? Functional. Um, Battery packs shall battery packs. Just a second. Right. So battery packs, what is the functional requirement? We have battery packs shall be um, resistant to punctures or crashes. Performance. Battery pack shall charge and discharge at zero point 0.6 C. Okay. I mean, these are all requirements, right? Of course, I'll just go right. It's not BMS. I'll just say battery 001, battery 002, battery 003, battery 004, battery 005, battery 006. So before I move forward, I just want to ask if everyone is okay with what I've done. Yesterday, we started with requirements. I showed you the number of requirements that we had generated. I will ultimately take you there. I'll show you how you can use some open source tools, AI tools to be more specific, to basically get it done. You don't have to do everything by hand, not needed anymore. So we will, of course, look at all of that. But before we do that, I just wanted to ask if anyone has any questions here, if everyone is okay with what we are trying to go through here. If you have any questions, do let me know. What I'm trying to do is I'm trying to show you how exactly we will come up with designs. Your customers most of the times might or might not have these requirements with them, but you need to have the requirements, because unless you have the requirements, what usually happens is something might go wrong with the product and the customer might come back and say, hey, you didn't design a proper product, right? So usually happens like that. So we tend to kind of be on the safer side. You will have to be safe. So battery material, battery chemistry, right? So you can say battery shall be 18650 LFP cells from a reputed manufacturer. Hope this is what you wanted to, you know, what you were meaning. So we can probably do that, right? And where does this come? This is a design requirement, right? You can say the BMS um, should be ASIL D-rated, right? And it will be a performance requirement, right? Or it can also be put as a safety requirement, right? Because it's ASIL D. But we still have not seen what this ASIL and all of those things are. We still need to look at that. But for now, I want you to focus only on this, because this is what we're gonna take and this is what we're gonna, kind of like move it forward. So we are just gonna look at only this particular aspect of it. Okay. I mean, yeah, you can derive it from here. Now I'll tell you how usually you do it. So here there is not much which people have given you. Assuming that you only get this particular particular requirements from your customer, how do you go and like say like there's a question which is the weight of the battery, right? How do you derive that? So now what I will do is, right, I will insert a column. Usually we do that, right? Okay, insert a column. um, and let me just copy this here and call it parent ID. There's no parent IDs for this, right? But now we are going to do a parent ID, right? So I'm going to say, let me just, okay, B009. I'm going to say parent ID is B005, okay? And I'm saying B005 says that it can be capable of being carried by a single person by hand. So now you tell me, what is the maximum weight that a single person can carry in their hand? Assuming that it is an average adult, what is the weight they can lift? Probably 15 kgs, right? So I can say battery pack weight shall not be more than 15 kgs, right? And it is a user requirement, right? But now this is no longer a user requirement. This is becoming a design requirement or a performance requirement, design requirement, whichever one you want. I've just said 15. We can say 5 kgs. Okay. So let's say 5 kgs. Now let's be very pragmatic. And can you tell me what battery pack size can we make if it is only 5 kgs? What is the average weight of an 18650 cell? Let's probably open a new window, right? And say, what is the weight of LFP 18650 cell, right? So about 40 grams, right? So what is the max voltage and I can, what is the max I can get for a let's say a 60-volt pack using 18650 cells, if the battery pack weight cannot be more than 5 kgs, right? I mean, there's no reason why you should probably sit and try to do the calculation on your own. I mean, you can, of course, but now that these are a little advanced right now. So it says that 8.5 Ah is basically what you can use for it, right? So now I would say that a typical two-wheeler, you would need at least about 30, right, or 40 Ah or something like that, approximately. So which basically means that I can come back and say the battery pack shall contain 3 independent modules in parallel, adding up to 30 Ah. I mean, I might be wrong. I'm not doing a full-fledged calculation or something. I'm just like trying to show you how this works. So this is again B005, right? Or I can say that there are two parents. It's not just coming from 005. It is basically because of B009, right? So I can say 009 is broken down into this. So why do I have a 3 independent module, right? I need to go and look at 9. So the 9 basically says battery pack should not be more than 5 kg. So why should battery pack not be more than 5 kg? Go look at 5. It says that you'll have to be able to carry it by hand, right? So the reason you'll say require 30 Ah for satisfying, let's say B003, right? And let me change B003 and we'll say that battery pack shall deliver a minimum range of 100 kilometers. Okay. So you need 30 Ah to satisfy B003, and B009 says that it cannot be more than 5. So you'll need to have three independent modules. So design your battery pack so that there are three independent modules, and each of it is, probably like about 8.5 Ah, and together they're kind of taking you to 8 threes are 24, 25, 25.5, or maybe like you can have contain four independent modules, right? So not three, four. So now I think you should have an idea about how the requirements engineering happens, right? So usually your customer is not someone who will have the answers for everything, right? So usually they do not have all the answers. They in fact don't have much answers at all, right? They'll just ask you to help them out with it. So now you as a systems engineer, what you're trying to do is you're trying to take their basic requirements which they have, and you're trying to break it down. Requirements can further be broken down into smaller areas, and you have kind of arrived at this particular point, right? So is this clear with everyone? Any questions here? Anyone has any questions? I hope I made it very clear, right? So we started with the battery pack, right? Where is it? We started with the, give me a minute. Okay, it's here. Right. So we started with the battery pack, and we kind of like understood how to build a battery pack. And now we have kind of gone forward and we have written some requirements. And one of the requirements says that the BMS shall be capable of maintaining a safe cell temperature between 50 to 45 operating condition, right? Now, you can, of course, go break it down even further. You can go and say that, this has to be broken down even further. We'll need to kind of have more of this. There can be a lot of things, but I think what we can do right now is we can go and we can probably think of doing a small, failure mode analysis on this, right? So let's kind of go do that, because now that we have a requirement, we should do a failure mode analysis, right? I mean, that is the obvious next step. So let's do a DFMEA, right? And I'm not going exactly with what what the industry standards are. Every single industry will have their own standards. I'm just kind of like having some small changes in order to kind of like make it easy for us to understand how we can basically work with it. So we'll need to have failure effect, um, failure mode effect, failure effect, and cause, and failure. Okay, right here. ID, failure mode, effect, FFE, cause, and severity, occurrence, detection. Right? This is the SOD parameters that we need to do. So once we do, we'll have action priority. We can have it like this, right? So let's now think about what are the ways in which your battery pack can fail, right? So let's start with this particular requirement alone, and let's kind of try to decompose that, right? So the reason I'm trying to do that is because this is kind of like a pretty nice requirement for us to go with. So let's kind of just start here, right? And let's try to break down how can we fail this particular requirement, right? I want you to probably like go ahead and see like if you can probably like type out in the chat window, right? And let me know what do you think are going to be the possible failures which can happen. How can we or how can the battery fail, and how can the battery not maintain that particular operating temperature? So that's what I want to understand. So think of all the ways in which the battery can kind of like exceed the temperature, right? So for one thing, we can say, um, outside temperature, not outside temp, yeah, outside temperature has um, has risen to 55 degrees, right? Um, Heat soak results in bat temperature of 50 degrees plus. I mean, I'm just giving. So either the outside temperature is risen or the heat soak, you have a black color car and the battery pack is sitting inside. The car is parked outside. And because of it, like it's kind of like become extremely hot, right? The insides have become extremely hot. That is heat soak. Yeah, lack of ventilation is correct, right? Or we can say too much charging, fast, too much, I mean, fast charging, right? Not too much charging, fast charging. Basically, we can also have overcharging, right? We can have over discharge. So basically, charge and discharge above the safe limits that can also cause these problems. Temperature sensor failure, right? We can have similar problems happening if the temperature sensor has failed. It can actually fail or it can give wrong information. So let's say temperature sensor, wrong information can also come in, right? That is also very much possible. Um, we can say that there is a temperature gradient inside the pack. So what you say is, I have two temperature sensors which are mounted because I don't want one of it to fail. But what has happened is the extreme edges of the pack, they're all very cold, but the center cell alone has become hot because it's not cooled properly, right? Which basically is temperature gradient inside the pack. Temperature is not even, there is a gradient. We can also say cooling is not sufficient, right? Or cooling pump fails, cooling circuit is blocked, right? So anything else that you can think of? What are the other different ways in which you can think of which might cause it to fail? Anything else? Yeah, SOCDOD basically comes in over here, right? So there's a problem with that. Um, we can also probably, I mean, we can have a lot more of things, right? So we can say that mechanical failure in one of the cells, puncture. There can be a lot of things like that. But what we are trying to do here right now, right? So we'll say DF, this for the battery, 0, 0, 1. DF for battery, 0, 0, 2. DF for battery, 0, 0, 3. Let me just, DF for battery, 3. Now let's try to have this here. If it is a removable battery, how will coolant systems come? I don't know. It's a question we'll have to answer. It's a question the design has to answer, right? Um, which is the reason why people do not want to go with removable battery packs. But unfortunately, our customer has asked for it. If they've asked for it, we'll have to do it, right? We cannot do away with it. We will have to do it. So now it's a very valid question, right? How do you cool when this happens? So now you can probably note here, reason or notes. You can just say that cooling is going to be a problem. Validate, right? We can do that. We can ask the customer that, hey, do you really want a swappable thing? And if they say that no, my entire business survives on swappable batteries, you will have to give them swappable batteries. There is nothing else that we can do. So most probably what we can do is if it's a swappable battery, usually we'll try to restrict certain other things, but we'll come to that, right? We'll come to that. Now, what you're actually trying to do here is that you are a subject matter expert. You hold doctorate in the thing. You have a lot of maturity than your junior engineers. So you're telling your junior engineers, hey, this is all the ways that I foresee that things will break, things will fail. Now, I want you to think about ways in which we can prevent it from happening, or I just want you to propagate the fault and find out what might happen. Just that, nothing else, right? So I just want the juniors to do this because, see, in an organization, you're working with a team of 20, 30. If you're typically someone with about 15, 20 years of experience, you'll have about 15, 20 people working under you. So they are supposed to sit and do this effect and cause and not you, right? So which means you should kind of like be able to push them to basically do these things. But in that case, they need a starting point. Starting point is what you're giving. You're telling them these are all the failures. Now tell me what the effect will be, right? So the effect outside temperature has risen to 55 degrees. What do you think the effect is going to be, right? So the effect would be that battery pack temperatures rise to um, limits, right? Cause environmental not in our hands, right? Heat soak. What will be the effect? Again, what is the cause? Like someone had mentioned, improper ventilation. Fast charging. What is the effect? Cell internal temperatures rises, right? Why does it happen? Because of RNT, right? The internal resistance will cause it to rise. Similarly with, okay, cause. Why do you allow fast charging? Because you can't just simply connect a fast charger and ask it to charge. This will be because of improper BMS onboard charger calibration. You might have a wrong calibration which goes into it, right? Overcharging, temperature sensor failure. It can be sensor failure, right? Now I will have to kind of like make it granular. I can't have different effects, or I mean, okay, different. This is not effect. This is a cause, right? So effect is um, coolant system does not act in time, right? Temperature sensor failure, or it can be CAN bus failure, right? Or it can also be like probably like um, BMS uh, miscalibrated, right? So this is temp sensor co- failure, communication failure, temp sensor um, interpretation failure, right? Um, So I'm just saying that you have everything working fine, but it is being interpreted wrong by the BMS. So it is not exactly a failure in the truest sense, right? But still, this is something which can still affect you. No one wants to do it knowingly, but it's basically that it can happen, and if it happens, this is basically how it works. So now what you can do is, let's say that we just take the temperature sensor failure alone and we say the coolant system does not act in time or something like that. Now what we can do is we can figure out what is the severity if in case the temperature sensor fails. So just give me some answers. If in case you have a vehicle, and yesterday I think there was a question and someone asked, when you hit 45-degree temperatures, vehicles are catching fire. Now you would see how we could prevent it, right? So now I said not all manufacturers will do these work, right? Very few people actually do this work. So now what we are going to do is we are going to see what would be the severity in case this temperature sensor fails. Go give me some answers. What do you think might happen if the temperature sensor fails? How severe will it be on a scale of 1 to 10? If the sensor fails, the coolant system does not act in time. That is one thing. But what ultimately happens, right? Battery enters thermal runaway, right? Vehicle catches fire. Risk to occupants is high. Two-wheeler, maybe they'll drop the two-wheeler and run away. but when the vehicle is moving, they cannot like kind of like drop the vehicle and run away, right? If it happens in the middle of a highway or something, then there is a risk to occupants. So now in this case, I want you to think, what score will you give for severity? How severe is this failure? On a scale of 1 is to 10, if you are someone who is paying for this two-wheeler, how severely will you take this? I would probably say 10 on 10, right? Maybe 9 on 10, 10 on 10. It's going to be extremely severe. It is not something which we can just leave it as it is. Um, I hope by 0 you meant 10. It's a spelling mistake. You cannot have 0, right? So it is 1 to 10 because you'll have to multiply it. So in which case, like if you have 0, it will not be possible, right? So it's very risky. It is 10, right? I was just pulling you, like trying to keep it little thing. Okay, now how often can this problem happen? Occurrence. How often can this problem happen? Now, if you are doing this, you will need some data for it, right? So you would probably say, if I am buying this from an unknown brand, unknown sensor, let's say that I just go to internet and I say battery temperature sensor, right? And I just go to shopping here, and someone here is selling something for 72 rupees. So suppose also, okay, let's say 65 rupees. Suppose I go buy this for 65 rupees and I put it in. Can I be very sure that this will actually like kind of last, that kind of a thing? Do I have any kind of a data about what is the failures? We call it MTBF, mean time between failures. So usually when you go buy it aftermarket, maybe a 34 rupee hobby grade sensor like this, right? If you buy it, this is going to have a lot more of failures. You use this in an Arduino board, or you use this in a piece of like a lab-based equipment. If something fails, then you just remove it, you put a new board in, everything is working fine. But you cannot basically do all of this when it comes to your automotive systems, right? So in that case, for automotive systems, what we are going to be doing is we are going to go for some standard suppliers, right? And we'll need to see who is basically able to supply us with this, right? What type of a temperature sensor do we need to use, right? I don't know. We'll probably need to have something which we can stick on to it. Um, Infrared will definitely work, but I don't think that that's going to be possible here. So probably you might want to use a thermistor based one here, right? So you kind of go try to find out who's the best possible person here. Omron is a name which comes to mind, right? Pretty standard supplier. So now what you do is, suppose you go buy a sensor from Omron or Panasonic or something, right? What is your occurrence? How often do you think it can occur? Pretty rare, is basically 0 to 3. But because it's a very big problem, let's give it a score of 4, right? I don't want to underestimate the problem here. Okay. Now comes the important thing. If suppose a temperature sensor has failed, is it possible for you to detect it or not? Will you be able to detect a temperature sensor failure? Very quick question. Will you be able to detect a temperature sensor failure? Any idea? How would you detect a temperature sensor failure? Onboard diagnostics basically needs to be engineered. So we cannot use an OBD here. OBD again is engineered, right? So UDS. Okay, very interesting, right? Mr. Paul Durai, very interesting information for you. OBD is something which is mandatory only for IC vehicles, right? Internal combustion engines. OBD is not mandatory for electric vehicles. Electric vehicles will have UDS, right? So you cannot actually depend on it's okay. What I'm trying to tell you is you cannot actually depend on that. you'll have to be a little bit more careful about it, right? So why? Because it is a very high priority item. Severity we have given 10, so it is a pretty high priority. So now, ideally, I want to give it a score of 4 so that I am able to get an action priority of 160, which is pretty critical, right? So anything above 80, I would probably put it as a critical one. So this is a highly critical priority. So let's just do this first. Is this red? Yeah, this is red. So let's just do this first, and then let's kind of see how we would be able to contain it. Now we have given it a score, but ideally what we should do is we should kind of go also add to our requirements. Now I'm going to do that. So now, how do I make sure that the occurrence is 4? I go to stakeholder requirements, right? And B011, and I'll say the battery pack shall have a minimum of 4 temperature sensors, right? This is a requirement that I'm having. And I don't want the temperature sensors to fail all at once. So what I'm going to say is all 4 temperature sensors will be connected independently to the BMS. So that even if one sensor fails, a wire is cut, the others are still acting, right? And now, in order to still kind of try to find out if whatever problem has happened, and suppose the entire thing is done, I still need to have some kind of an idea. So what I'm going to do is same make and model temperature sensor shall also be connected to the to the um, VCU as well, right? So I'm saying that, hey, you are not just going to be using 4 temperature sensors. I'm saying that send wires individually to all the 4 sensors to the BMS. And you will also have 1 or 2 more similar sensors which will not connect to BMS, but it will connect to VCU. So what I'm effectively trying to do here is that I have my battery pack. Sorry. I have my battery pack. I have my BMS. And I'm saying that you know what, send me 4 different values, and the 4 different values come from all 4 corners, right? So 1, 2, 3, 4. So I'm kind of trying to like say that there is independent wire, so even if one of it gets cut, I still have the others. Is there any criteria for rating severity based on data? What if product is new in market? There is some guidelines. So you will have to go read this IATF 19649. I'm not very sure, right? It is called AIGVDA. This is a standard document, right? It's like an ISO standard. I mean, ISO 9001 for automotive companies is basically this. So, how do we assign severity, occurrence, and detection SOD parameters? This is something, there is standard definition from AIGVDA. This will also be further implied by Tata, Mahindra, or if you're working with some international companies like Ford, GM, they'll have their own quality systems, right? So these are all part of their QMS, quality management systems. So every single company will have their own independent way of figuring out what is the criteria. We will have to follow that criteria. So how will they list the criterias? So we can just go search online, see if it is available. IATF guidelines for SOD ratings, right? So there's the internet. IATF stands for International Automotive Task Force. So you go here and they would basically, I mean, it's like um, it costs a lot, right? You won't get the documents like that. It is like pretty difficult getting it, but they will probably like have all of those details listed out here, right? Somewhere here, or okay. So now this is probably something here. So if it is catastrophic impact, 9 on 10, major impact, moderate, minor impact. So everything would probably be, something like that. So now why did we go for 4? Because low, isolated, or infrequent, right? So that's basically like why we went for a 4. Very low is extremely rare, right? So let's say, for example, what has got a very low failure rate? Aircraft engines, right? They should make it to that 1 or 2, right? So detection, how do we do that? Detection is very easy, right? So it is high. Very low means there is no detection method available. It is a reverse scoring as far as detection, so which is why we've given a score of 4. So, but just because we have given a score, it does not end here. We'll have to kind of make sure how we are going to do that. So now to make sure that we have multiple sensors, we have this. Now what I will do is for detection, in order to make detection possible, I will say VCU shall carry a algorithm for temperature sensor rationalization. BMS shall perform multi-sensor uh, data credibility analysis. I mean, don't ask me what it means. I'm just telling something which comes to my mind. Of course, I'll have to expand it, but I'm saying the BMS will not just take one sensor value and work. It'll take four sensor values. It'll analyze what the four sensor value says. It'll try to figure out if everything is right or not. It has to basically do something like this, right? But the ultimate goal here is to kind of tell you that you cannot just say that, okay, there is a BMS and I need to put a temperature sensor in the BMS and be done with it. I'm just trying to tell you that it does not work like that. So now one requirement here, right, has kind of like given rise to, 3, 4, 5 other requirements, right? So like this, what you do is as you start doing the same things for multiple other parameters, DFMEA modes and things like that, for every time that you need to mitigate a certain failure, you need to come here and put a new requirement, right? So which means even before you can make a very simple battery pack in your college, if suppose you're doing it for an industry, you'll need to basically make sure all of this is met. Now, I have not gone into the other things. Now, I'll also say what are the standards that automotive grade battery pack must meet to get homologated in India, right? AA is 136, 156, something like that, right? 156 and AA is 038, right? So there are two things. Um, so now this is basically what you'll need to satisfy. Now, what is AAS 156, right? So AAS 156, you go there. Um, it should be available on our eyesight, right? So you go here. Uh, okay, I hope they have. Okay, that is not. Um, okay, let me see. RI. So go here, and where is AAS 156? Sorry, again, just give me time. Right. So you have AIS 156 here. So now if you go to AIS 156, so it's basically going to tell you what are the standards that you'll need to meet if you're building a battery pack and if you need to put in a vehicle and if you need to sell it in India, right? So there is quite a lot of things, right? So now for thermal propagation, it basically tells you what exactly is needed and how is thermal propagation going to be like defined, what is thermal propagation, right? And how are they going to test it? You'll have to give them a battery pack and they will test it. And only after they test it, they can basically homologate it, right? So you see here. So if you are able to meet all of these parameters, that is basically when you would be able to sell your battery pack in India, right? So now it says your battery packs will have an IP rating, I think 67 or something, right? You should have an IP rating for the battery pack. You should have all of this, right? So over voltage, overcharge, over discharge. These are all the protections which you should have. Suppose you have an onboard charger, then what are all the chargers it has to do? So there is quite a lot of specifications which they've given. And in fact, one of the major work that I do on a daily basis is to extract requirement from this, right? Just a second. 1 minute, just give me a minute. Yeah. So one of the major work that we do is to go ahead and extract requirements from this. Now, how many pages is this, right? If you go down, it's about 100 pages, right? Okay, maybe 60 pages of it is actually text, 40 pages is all definitions and things. But you will have to extract all this information which is in a PDF format. You'll have to extract it and you'll have to put it here in a requirement sheet. So now whatever is there, right, which is over voltage protection, under voltage protection. I mean, of course, we did have all of this mentioned here, so which means all of this, the government has also taken care of it to a great extent. So I mean, which is also how it works, right? So if you are compliant with AS 156, a lot of DFMEA will get taken care of. But irrespective of it, if you don't know AS 156 exit, you do DFMEA, you'll be, probably like you'll be, working with that as well, right? So this is the first aspect that I wanted to tell you, which is whether it's a motor or a battery pack or something like that, you will need to kind of make sure that there is a lot of these failure modes which are analyzed, and each of the analysis will give you new requirements, right? So now you would probably know, okay, if I'm designing a battery pack, I should use at least four different sensors. I should make sure they all carry individual wires back to the BMS. Why can't I have a can or something there? Because if a can fails, then it is a single point of failure. Why should I make sure there is no thermal gradient? Why should I make sure that there is sufficient ventilation? Why should I put a fan under the battery pack? Why should I, even when the vehicle is switched off, the fan should work? So I can say VCU should be capable of switching on the cooling system even when vehicle is off, right? VCU should be capable of um, using the 12-volt system to switch on cooling fans when HV is off. Because sometimes what happens is the cooling system, the HV system, right? Okay, rather we can write it here. We can say um, thermal management system should work only with low voltage system, should work not only with, should work with a low voltage system. Why? Because your high voltage system, usually you will disconnect it with contactors, right? So when your vehicle is switched off, you will have your contactors switched off. So which means your high voltage battery pack, the main battery pack, is not going to be functional. What will be functional is your low voltage battery pack. So your cooling system is working on the low voltage battery pack. It's trying to cool your battery. And now we can introduce one more, right? We can say whenever LV pack charge goes down, HV should charge even when vehicle is off, right? How do you know if LV pack charge goes down? LV pack charge SOC shall be monitored by um, VCU at all times. You cannot have a BMS for it because BMS will also be put to sleep. Only the VCU will periodically wake up and will keep checking. So we are assigning the LV pack charge to be monitored by the VCU. Why do we do all this? So that even when the vehicle is switched off, right, And suppose in the DFMEA, because of heat soak, if temperature starts to rise, you do not allow the temperature to rise to 50 degrees. The moment it starts crossing 30, 35 degrees, your VCU detects it. It is switching on the fan. It is making sure that the ventilation is happening. So you are never allowing it to reach 50 degrees centigrade. So I'm pretty sure if you design a system with so many thought process which goes into it, then basically you'll not have to worry about battery catching fire or something. Now the question is, what batteries actually do catch fire? The only batteries which will catch fire are those from companies which do not follow all these principles. Only from those companies which do not have experience implementing it. Which is why I say Ather does not have much failures. Tata Motors does not have failures. Maruti will not have failures. Toyota will not have failures. But if you were to look at a battery pack which comes from a small startup, if you were to look at a battery pack which comes from a startup which is only focusing aggressively on growth, do you understand that it is very much possible that they might have not done it properly, and because of that, some failures could come in? Now, you might ask, why is it they didn't do it properly? Because to be honest, this whole exercise to complete would take you about 2 to 3 months. Now imagine just next time a startup comes to your college and they want to talk about battery packs and they say, how long will it take for you to build a battery pack for me? You tell them that, hey, it'll gonna take me 3 months and I'm gonna charge you 10 lakhs for designing it. They'll run away, right? Startups run away because they don't understand there is so much of things which you need to do in the back of it, and they don't really understand why do we have to do. But if you do understand, then it basically becomes much more easier for you to understand, even if you go into the market. Right? I come from Coimbatore, so there are people who manufacture battery packs here. There are people who will sell me a 48 volt 30 Ah pack for, let's say, like 40, 45,000. There are people who will sell me the same pack for about 30,000 also. Same cells, same manufacturing process, everything same. But a 40,000 rupee plant probably has much better quality management systems. Every single cell is basically measured. They do multiple rounds of testing. They will never slip up. They have that kind of a quality. They are also IATF accredited, right? Whereas someone who is not will probably not be allowed to supply. In fact, right? In fact, there is a very interesting thing. If you want to be a if you want to be 19649, right? Um, certified suppliers. So if you want to be a vendor who can basically supply to, okay, it's here, right? If you want to be a vendor who can supply to Maruti or someone like that, you people might have startups in your organization. You might probably be, mentoring some startups and things. Unless you have an IATF 16949, not 19649, 16949 accreditation, you are not going to be allowed to supply parts. So, which is why if you look at it, some of the OEMs say we are giving a lot of incentives to startups to start supplying. We are going to work with startups. The reason why they do it, the reason why they kind of make it such a big thing is basically because they are relaxing these requirements. Because the startup is not going to follow all the things, so they are kind of basically relaxing it for you. Okay. So I think this is part one of what I wanted to speak about DFMEA and let me just go through this. Right, DFMEA, DFMEA. Yep, I think okay. I think I'm quite okay with it. So now, does anyone have any doubts with respect to this? How do you understand how failures occur? What are the failure modes? So DFMEA is something which we have covered. And now, before I think we have the last 40 minutes now. I would like to take you to another very important, topic, which I think everyone should basically learn. So that's called HARA, right? Hazard assessment and risk exposure analysis. So, any questions here? Is everyone okay with what DFMEA is? How do you do DFMEA? What are the process involved with it? Any questions with respect to this? You're all okay with DFMEA? If you have any questions, do let me know. Okay, so now what we'll do is we'll go to a very interesting concept called as functional safety. So this is an ISO 26262. It is also referred to as FUSA, functional safety, right? You go to Naukri or something, you will find a lot of talks being put up on functional safety. Now, your severity, occurrence, and detection, whatever you do for DFMEA, similar concepts also apply here. But usually, what we do is while DFMEA is applicable basically for any product, it can be a mechanical product or anything like that. Functional safety usually is kind of used for electronics or electromechanical products alone. It will not be allowed for, it is not basically followed for pure mechanical products, right? Mechanically you can design everything, right? But our idea right now is when there is a software component also which is involved, how do we make sure that the whole concept, the whole algorithm is safe? The function which you are trying to build, how do you ensure that it is basically safe, right? So that is what ISO 26262 is, and we will start with a very interesting definition of functional safety. So functional safety, the main aim is to reduce risk. Okay, let me underline risk. Now, when I was talking about can AI models be used for safety studies and failures? Yes, it can be. Uh, but to what extent is a question that is an area where I'm currently doing a lot of research on. But it's something where you cannot just simply go ask ChatGPT to do it. You'll need to kind of you'll need to make sure that there is audited proof. It's not something which AI can do directly, but it can be made to do. That is an area where I work a lot on. My one of my startups, we are working on using AI for quality management systems. The company is called Gear Merit. I can probably show you some of the artifacts towards the end of it as well. Okay. Now, let me just go back to the questions. I think Professor um, um, I think Dr. Venkatesh had said that it is risky, right? So, Dr. Venkatesh, I'm going to hold you on to it. So, I want you to tell me what is risk, right? So, you had mentioned two times that it is risky. So, what is risk, right? Um, what are the grades of LFP with different life cycles? What determines the different life cycles? I mean, LFP life cycles is like more or less somewhere about 1,500 to 2,000 cycles is what is there. But the life cycle depends on the C rate at which you charge and discharge, right? And I think you will probably have to go with something like a standard testing agency to kind of do it, because there's a lot of marketing gimmick also happens around life cycle. So we need to kind of like be aware of what it is. So I would say anything more than 3,000 cycles is a little I don't know if it can actually happen, right? But coming back to it, it's an earlier question you have asked for rating. No, no, I said, how will you define risk? What is the definition of risk? So I know it was regarding the earlier question, but you use the word risk, right? So now if suppose like I ask a question here, suppose I take a um, scooter and I drive on a express highway. You know that two-wheelers are banned on express highway, right? Bangalore, Mysore. I don't know about the other one, but the Bangalore, Mysore express highway, two-wheelers are banned. Hyderabad Outer Ring Road, two-wheelers are banned. They say it is risky, right? But what exactly is that? Or let's say I take a scooter and I drive on an expressway. Will you say it is risky or will you say it is not risky? Someone might say risky, right? Someone would say not risky. But then I'll ask you another question. Suppose you have a choice of taking a scooter or a bike on the express highway, which is now more risky, right? Or let's say you have an option of taking a car, right? Which is now more risky. Or let's say you have some German SUV versus, let's say, train versus plane. People will have different opinions about what risk is. Now, if you ask a 18-year-old student, they'll say, no, it is absolutely safe. I'm going to drive properly. I don't have any problem. I'm going to be okay with it. Right? Correct, correct, correct. Right. So now probably I can ask the same question a different way, Dr. Venkatesh. So I can say an EV two-wheeler versus ICE two-wheeler, which is risky, right? So what I'm trying to say is the risk is basically something which depends on the people. Now, if you ask me, um, probably like, okay, let's not take a car, let's take a bus, right? 15 years back, I was someone who would travel everywhere by an omnibus, right? I was okay with it. I've slept in the last seat. I've done all that. I was okay with it. But now, if you ask me any chance that I get, I probably prefer taking the train. Even if it means staying back and taking the next day or something, I prefer taking the train. I kind of feel that it is more safer to take a train than travel by bus or bike for that matter. There have been time when we have traveled quite a lot of distances on the bike, but now I don't want to do that, right? So the whole concept around risk is something which is not fixed, right? So the first thing that you need to understand is the concept of risk is not the same for everyone. Risk is something which kind of like keeps varying a lot. So when it is something like that, how can you say that, hey, an EV two-wheeler is risky, right? And an ICE two-wheeler is not risky. Let's go scientifically. Let's go qualitatively. So if you think that a battery catching fire is risky, the petrol tank probably leaking and catching fire is equally risky. How is it that an IC vehicle, you don't have a problem about the petrol tank catching fire, whereas with an EV, you have a problem with the battery packs catching fire, right? I would say, okay, let me answer that question first. I would say if OEMs had probably started building electric two-wheelers, I'm talking about the Hondas and TVS and heroes of India. If they had started building electric two-wheeler, you would probably not have even known that electric vehicles were risky. The reason electric vehicles started becoming risky is because of China imports. That's where we started with Chinese imports, startups, people who basically didn't spend time in the industry. An average startup, EV startup, is done by someone who has got minimum of about 2 to 5 years of experience. Whereas there are people in the automotive industry with 15 to 30 years of experience who still kind of like do all this process, right? So there's a lot of difference there. So let's leave this out and let's come back. What is risk? If risk is something which you cannot like define directly, then how do you kind of say that something is risky and something is not risky? How do you basically do that? Right? So the definition for risk, at least from a functional safety perspective, they're kind of able to define it in a much more easier way. They say that the risk is a product of severity. We've already done it, right? Exposure or how often does it occur, right? Multiplied by there it was detection, but here it is controllability, right? So basically that you kind of like need to have some means of like controlling if one of the electronic goes wrong. It's not a mechanical failure, or it's not a failure in the physical sense that you're talking about here. It's a failure in the function realization. What if your temperature sensor is not able to detect a temperature rise in the battery pack? What will happen in that case, right? This is basically a parallel topic, it is not the same as DFME. So that's why I'm trying to like go through this right now. It is completely on a parallel topic. So for severity, we will go from S0 to S1, S2, S3. Similarly, exposure E0, E1, E2, E3, E4, right? E can go, exposure can be like 4 also sometimes. Controllability will be C0, C1, C2, C3. So S0 would basically be something where there is no injuries which can happen, right? S1 would be light injuries, severe injuries, and life-threatening injuries. Exposure is almost zero, right? Almost zero, low, sorry, very low, low, medium. Exposure can be high, right? Controllability is you can completely control it. I'll tell you what this is, right? C1 is you can, by simple methods, you can control it. C2 is normally controllable. C3 is difficult to control. Let me kind of like just still take it in a chart. ASIL evaluation chart. Um, I think this is a pretty good chart. Page. Okay, I hope this is visible, right? So this is the ASIL chart, and like I said, an ASIL chart is something which helps you understand what is the risk which is involved with a particular system. Now let's go with a use case here, right? Let's say um, powertrain. Okay, let's say motor torque request, right, which is asking the motor to deliver torque, has unexpected spikes, right? So basically what I'm saying is motor is delivering 15 Newton meter and in the next instant within 100 milliseconds, right? So the motor is suddenly delivering 80 Newton meters now. Okay. I mean, it's a hypothetical situation, but please bear with me on this, right? You have a condition where you have done everything properly. So the user is suddenly given full throttle. I mean, it can happen, right? 100 milliseconds, probably. And motor was giving 15 Newton meters of torque. Now suddenly 80 Newton meters of torque it has to give. Why? Because you directly connected your throttle to the motor control unit and suddenly he gives throttle, it has to deliver this. Now you think and tell me if this is basically something which is happening, right? This is a failure. The function is not supposed to behave like this, but in case it behaves like this, can you tell me whether it will be severe? What is the score you would give for it in terms of severity, in terms of exposure, in terms of controllability? Can you tell me what not? The scores are not 8. Scores are S1, S2, S3, E1, E2, E3, E4, and C1, C2, C3. Right? So rather, I mean, so this is just giving you a score on these slides. So for this, what would be the severity score? What would be the exposure score? And what would be the control score? Look at the image on the board and on the display and tell me that. So can you look at it and tell me? So suppose if the torque is suddenly coming in, what do you think will happen? Probably the vehicle will skid and the rider will fall. That is what I'm assuming will happen. So I'll say skid and fall. So in this case, it can be life-threatening injuries, S3. Let's now look at exposure. Do you think it can happen at what times? I mean, so exposure is basically about how often can this happen. So now, will the exposure happen? Is it possible for it to happen? If there is no mitigation, it can always happen. So this is something which is E4, right? And now, is it possible for you to control it? Look at control. Is it possible for you to control? Is it simple to control, normal control, difficult to control? If it is a person driving it on the track, right? If it's a racing driver driving on the track, it would be C1. They can control it. But now a person driving on the road is very difficult to control. So it goes to C3. So which means now it's got a rating of D. So this will get a safety goal of ASIL D. ASIL D basically means it is a very highly important safety goal. You cannot take it as it is like that. It is not a very simple case here. Torque request, what's going to happen? I'm connecting my throttle directly to motor controller. You cannot, right? Now you understand why you cannot. I'm supposed to put a throttle going into the VCU. Inside the VCU, there is supposed to be a torque monitoring algorithm which sits in there. Anytime the wheel speed rises by so much within 100 milliseconds, I'm supposed to cut the torque. Even though the driver might ask for it, I'm not supposed to do it. I'm supposed to implement a traction control system. I'm supposed to put an ABS system because motor torque going from 15 to 80 is a problem. Motor torque coming from 80 to 15 is also a problem. Regenerative is also a problem, which means I'll need to put a torque monitoring software into it. Now you understand why an OEM ECU is actually expensive. Developing it is expensive, right? It's not that easy. We'll need to take into consideration all of these things. So all in all, torque spikes, whether on the positive or negative side, ASIL D, highest safety requirement which we need. Now let's quickly do one more example, right? So that we'll kind of like understand what might happen, right? So let's say that we have um, temperature sensor failure. Okay. Now let's say that there are two sensors which are present and only one temperature sensor is failing at any point of time. Or even if you take both of it failing at the same at the time, right? Two temperature sensors failing at the same time, both of the temperature sensors are failing. Now, if in case temperature sensor is failed, then what would be the mitigation? Imagine, I mean, remember we have four temperature sensors and we are saying that two temperature sensors has failed. Now, in case temperature sensor has failed, right? What is going to be the severity? Battery pack will get into thermal runaway, right? If it gets into thermal runaway, what is the severity? Let's assume it is going to be S2, right? It will catch fire, but you can leave the vehicle and run away. Smoke will come first, you can leave it and run away. There is going to be cover. So before it becomes more extreme, maybe you can run away. Let's say it is S2. Now you have got the temperature sensor from Panasonic, and they say 1 ppm, 1 part per million is the failure rate which we will have. Now, what is the probability that both the temperature sensors will fail at the same time? Or you can even say all four sensors will fail at the same time. What is the probability that all four temperature sensors, or let's say that you have only two temperature sensors, right? Let's just take that you have only two temperature sensor. What is the probability that both the temperature will fail at the same time when the temperature sensors are supplied by a Japanese company like Panasonic or Omron? I'm not talking about a local supplier who sits somewhere in a market and makes a temperature sensor, or they are importing cheap Chinese sensors. No, nothing like that. I'm talking about a branded Panasonic sensor. What is the exposure? Exposure is a probability. I would say it is very low, right? And in case the battery pack catches fire, what will happen? Can you control it? As in, control the vehicle, stop the vehicle, get out of the vehicle. What do you think will happen? It's not going to be E4, it's going to be E1, right? E1 basically means it's very rare that a failure can occur, right? It is E1. So let's say it is difficult. This gives us the quality safety goal as QM, quality management. So what it tells you is all you'll have to do to ensure that a temperature sensor failure does not affect your vehicle is to make sure that you have a good quality management process. Make sure you buy it directly from Panasonic. Make sure that Panasonic or the company who's supplying to you, they basically are IATF certified. If they are IATF certified, then they are more likely to give products which have very less failure rates. If it has a very less failure sale rate, you don't have to actively build torque monitoring, you don't have to do that. It is just a quality management process which you'll have to do. Now, let me kind of put it in a different way also, right? Like, let's say, for example, you know the power steering in a vehicle, car, right? Pretty much you have all driven your cars and you have a power steering. It's called the EPAS, Electronic Power Assist System. EPAS. EPAS is the power steering and the EPAS ECU, right? The ECU plus motor and the whole system. So this is a company which I work with. So it is called NSK, Rane NSK Steering or Rane Steering Systems, RSS, right? So they are one of the biggest steering component manufacturers in India. Now, the EPAS unit, when it goes to a normal car, right, they make sure that it is ASIL B rated, ASIL B rating. But the same EPAS ECU, when it goes to an ADAS vehicle, this goes to ASIL D rating. Same system, right? They were always selling it at ASIL B, but the moment that they started, I mean, we started having ADAS equipped vehicles in India, right? Tatas and Mahindras and whatnot, everyone is now coming with ADAS. The same ASIL B rated system has now moved to ASIL D. So what changed in that? Probably something like it's like going from B to D, right? So it's probably going from B to D. Probably here, that is the only place I see. Or it could also be like gone from here to here or from here to here, whatever the reason it is, right? Why did it become ASIL-D when you had ADAS? Because in ADAS, what had happened is you have now software completely controlling the vehicle. So if there is a failure and if the software is not able to control your vehicle, then this becomes much more bigger problem. So for that reason, in this case, the ASIL rating has moved from ASIL B to ASIL D. While we are talking about it, right? So if you remember how we have progressed, we looked at mechanical failures or independent failures, right? And very early, what we did is the moment that you had requirements, we looked at these, and this process was called DFMEA. The product itself failing, that is DFMEA, which we do. And then the moment you start putting electronics and software, right, E&D software into it, we started doing functional safety FUSA, right, which is a HARA analysis, right? Now, what can also happen is your cars are connected to the internet. You have over-the-air updates and things like that. So, which means now you can also will need, right? Because now it is connected to the internet and it is able to, I mean, run software-defined vehicles and things. You will also have TARA, threat analysis, right? So this is cybersecurity, which comes in here. And then you have another very interesting thing, which is SOTIF, safety of the intended function. This comes in when you start having self-driving cars, right? You might have read a lot of incidents where a Tesla was self-driving on the highway and it went and crashed into a truck, right? It did have self-driving. Self-driving was supposed to help people It was built with a very good intention in mind, but what was the safety of that intended function? It mistook a truck for a, I don't know, for a shadow or something, and it went and crashed into a truck. Or the truck was stationary, it thought it was moving, it went and crashed. So SOTIF is another thing which comes in. So there's a whole lot of things which comes in as you start moving, but you should at least be aware of two things here, right? So which I would say DFMEA and functional safety, pretty good for you to start with. Again, cybersecurity and SOTIF and other things, it becomes much more higher level things which you can only do if you have a lot of tools. But these are things which you can probably work with very less things in place, right? So I think that was kind of like sufficient enough for you to understand how the development happens. So now, of course, I didn't have much time actually going into all the whole process. We hardly had about 4 hours, but I hope I did do justice. But one of the questions which came up was, how do we use AI tools, right? So what you see here, I use a lot of AI tools for it. So can you just go and do, I mean, use an AI tool and can you just ask questions and will it be able to kind of just give you answers to it? More often than not, it will not be, right? But you can kind of prompt it in a proper way, then it might be able to. So you wanted to know what are the failure modes which are there in a vehicle. um, I actually do have a complete repo which basically talks about it, right? We've actually built something on those lines which will help you predict it, right? So that's a product which we kind of make. I'll just pull out a small slide alone, right? Um, okay. Right. So you cannot just go and probably like um, ask it to do DFME or something like that, right? So it will not be able to do. But what we can do is we can build an agent harness around it. You can have agentic AI working off a certain harness, which will help you build these things out, right? So we have these things. It is actually deployed in the industry. These are some of the things which we have, like say for example, our agents can run simulations on answers or Simulink or something like that, and it can come back and give you answers. There's quite a lot of capabilities which we are currently building, right? So this is just some of the things which we have done. We can also build similar models. If you look at it, pretty much the whole thing that I mean, I don't know if it's visible for you, right? So the whole product that we are working with, let's say the batteries and just give me a second. Where am I? Multi-CA. Let me just try to pull up something which I can showcase. Um, Cell predict. Where is it? Caption series. Oh yeah. Yeah. So this is basically something where we have built a cell prediction model, right? A single cell prediction model. This is something where you would be able to use this to go make some predictions about how your cell would work, right? So this, if you look at it, it is completely built in Python. Right. So what it would do is you can have any particular cell as long as you have an equivalent circuit model. There are some open source tools which we use, right? And we would be able to predict how the cell deformation happens based on whatever charge and discharge that you subject it to. Um, just preparing a white paper on the same, I would be happy to share it if you want. I also have the complete repo. I'll probably put up. Everything is open source, so I don't mind sharing this. If you're someone who's working on this, you can get in touch with our team. I've not completed it. I'm still working on certain things here. I can probably share it with you, right? So this is basically how it works. The outputs from here. So this is basically the heat generation curve, right? Everything is generated with Python. It's not any CFD tool. I'm just trying to develop everything using Python. So it's a very simple, fast tool which will help you predict failures, right? So now, how does it work here in battery? Maybe you don't have all of that, advanced tools, but you can still use quite a lot of Python and Python especially right now. I also use a lot of Rust, and we can help you build these type of research initiatives, right? So now if a question is, can I build a sodium battery, right? Some of you were asking that yesterday. So now we can help you model the sodium ion transport, or you already understand how this happens. You can use these repos and you can kind of simulate it, right? And of course, you need to have an idea about failure modes and other things as well. That's basically when your research becomes industry ready, right? If you're wanting to commercialize your design patents, then these are things which you will have to look into. So I think I'm going to stop with it here.